Integers. We're going to talk about sets of numbers. The smallest set we most often use are integers. It's not the smallest set of numbers. Before integers, you have, here I'll draw a little picture. So you have what's called the natural numbers. And those are the counting numbers. They're natural. You start 1, 2, 3, and then you can go on forever. That's the smallest set. And then the next set you have are whole numbers. And that starts at 0 and then goes 1, 2, 3, etc., etc., etc. And the natural numbers fit inside the whole numbers because this is 1, 2, 3 forever, and this is the same exact thing except we've added 0. And then we have integers. Okay, and integers are all of the positive and negative whole numbers. So on a number line, it's every positive number and it's every negative number, and it goes on forever in 2 directions. The natural numbers and the whole numbers only go on forever in 1 direction, whereas the integers go on forever in 2 directions, positive and negative. And we know that you can get hugely negative because we have a $1 trillion national debt, right? So the integers, wow, that's a really bad circle.
Like a potato.
Yes. The integers contain the whole numbers and the natural numbers. So like the whole numbers contain the natural numbers and then the integers contain both of them. And at this point, inside the integers, no fractions, no decimals. Okay, so it's only whole numbers, but it's positive and negative. I'm going to try to show you guys as many things as I can that make things easier for you, because, like I said, it's all about making it so that it's comprehensible. You know, it's not about like, no, you will do it exactly this way because I said so, and I am always right. Yes. I'm not dictatorial. All right. So we're going to graph each number on or locate each number on the number line. Again, if you're more comfortable, you can write it up and down. This is very difficult to do. Ready? -4. Hold on. I'm going to make a big dot. Right there. And we're going to label it A. Okay, -7. Right there. I'm going to label that B. Okay, this one's really, really, really hard. 0. Right there. Label it C. And 2. Label it D. Okay. Any questions on labeling a number line? Right. Numbers to the right or to the top, this is the larger side and this is the smaller side. So -11 is actually smaller than -9. And if you think about it, larger numbers are being more desirable. And if you think about negatives as debt again, you would rather owe somebody $9 than $11. So more desirable is better, greater, larger. Any questions on that? Is -11. Remember, the alligator mouth eats the bigger number. All right. Which is bigger, -7 or -4?
-4.
Right, because it's to the right. 0, 2. Okay. Alligator mouth is greedy. Wants a bigger number. Any questions about that? Good. Okay, absolute value. Absolute value is distance. It's distance from 0. That's what the definition of absolute value is. And distance is always positive. And if you think about that, it'll make sense. Distance has to be positive. It doesn't matter if I walk 2 miles forward and I walk 2 miles backwards, I still walked, 2 miles, right? Like just because I was walking backward did not make it negative 2 miles. If you drive backwards, it doesn't roll the miles off of your odometer on your car, right? Wouldn't that be nice? So distance is always positive no matter which direction you're going in. You're traveling a positive amount of distance. So that's why absolute value is always positive. So it can never be negative. So anytime you see it looks like parentheses except they're straight, it's absolute value. And again, it's always positive. So it doesn't matter what's inside here, what comes out is always going to be positive. So that's 5. That's 3. That's 0. Although that's kind of silly because there's really no such thing as positive and negative 0. But it's still considered kind of like positive.
Even if it has a negative, it doesn't.
The only time you'll get negative as an answer is if the negative is on the outside. See how this negative is on the outside? It just hangs out. The absolute value of negative 2 is 2, and then this negative just came down. So if I put negative on the outside, it's just, you're just carrying it down. Opposites. Opposite. If one is positive, the other is negative. If it's a fraction, it's the same thing. One positive, one negative. The definition is 2 numbers that are the same distance from each other from 0, the same distance from 0 on opposite sides of the number line. That is the definition of opposites, but really, one's positive, one's negative, same number. So parentheses, see it's curved, they can slide in. This is a wall. When you have a negative outside an absolute value, it's going to go bam right into that wall. It can't get in. It's going to crash and burn. So these guys have to stay lurking outside. They can't get in. So what happens then is the negative gets carried down, and then the absolute value of negative 12 is 12. Yeah. So he can't get into the wall. You can slide in around a parentheses, but you cannot go into the wall.
So if that negative wasn't there in the beginning,
it would just be 12, yeah. Same here with this negative. He can't get into the wall, so we just carry him down. Absolute value of 7 is 7.
He ran into the wall and fell.
Yeah. There you go. He ran into the wall and he fell down. That's a good way to look at it. Okay. Here's how you do this. We're going to make A in red, and then we'll do B in blue. You start at the first number. Now I'm going to add 3. To add, you move in this direction. If you're subtracting or if you have negatives, you move that direction. So I'm going to add 3. So I'm going to go 1, 2, 3, which takes me to 8. Okay. Or I can start at negative 5 and I'm going to add 3. So I go 1, 2, 3, and that takes me to negative 2. If I do negative 5 and I do positive 3, this is literally 5 minuses and 3 pluses. And I can pair them off. Every minus pairs off with a plus.
Whatever you have left.
And whatever you have left over
That's pretty cool.
is your answer. I have 2 negatives.
Seems like that would be quicker than actually drawing the line, the timeline itself.
If you have a big number, this can be pretty time consuming.
I bet.
Doesn't always keep the number with the high.
The bigger number, yeah.
Is there a case where you'll be given opposites and has to show that on that?
Like,
Would that work?
like if I did negative 5 plus 5, those are opposites. Yeah, so if I had 5 negatives and 5 positives, what's going to happen? They're going to cancel each other out. Opposites will always give you 0. Because they'll all pair off. You won't have anything left over. Trying to think. All right. Oh, I just did this. Okay. If you're going to use the number line, I have negative 5 plus negative 3. Yeah. So I'm going to start at, let's see, 0, negative 1. I'm going to go 1, 2, 3, because negatives go backwards, which take me to negative 8. Oops. That looks terrible. Okay. All right, you guys seem to be... Okay. I like the rule. Okay, the rule. It's like a matching game. If the signs match, you add the numbers and keep the sign. Okay, so if it's a matching game, they match, so you can combine them together, right? Or if you'd like to think of it, again, negative numbers are debt, positive numbers are income. So if you keep adding to debt, it just, if I owe you $10 and then I borrow $5 more, how much do I owe you? $15, right? So I add the numbers together and it stays negative. So, with that in mind, sorry, I have 2 negatives. I match. So I have negative 2 and negative 4, so I'm going to do 2 plus 4. That's 6. They're both negative, so it stays negative.
So what's the point of putting the brackets around it?
The parentheses, because this looks really confusing.
That it does.
Yeah. That's why the parentheses are around the 4. It's just to make it visually
Okay.
so that you're not going, whoa, wait, what? Yeah, that's all it is. It's just it's like spacing.
Morse code right there.
Okay, negative 12 and negative 37. 12 and 37 is 49. They're both negative. Okay, this one is really hard. There we go, 76. 2 positives you guys never have a problem with.
I would say
Okay, the rule for different signs. If they don't match, subtract the numbers. And you keep the sign of the bigger number. Now, I'm going to put bigger in quotes. It's not greater. Because if I have, let's say, negative 40 and 3. 40 is bigger than 3, but negative 40 is actually way less than 3. So that's why I say bigger number. It's not the actual literal greater number, because the greater number is always going to be the positive one. So what I'm going to do is I'm going to say 7 minus 2 equals 5, right? But 7 is bigger. So it's going to be negative 5 is my answer. So 2 plus negative 7 is negative 5. I owed you $7. I paid you back 2. I still owe you 5. Okay. Negative 6 plus 24. I'm going to do 24 minus 6. 18. And because 24 is bigger and it's positive, my answer is going to be positive 18. And negative 8 plus 8? 0. Same size. They cancel each other out. Okay, any questions on that? All right. The rule for adding opposites? It equals 0. Okay, there you go. That's called additive inverse property, by the way. You might want to write that down. It's called additive inverse property right here. Whenever you add opposites together, they are called, basically what they are is A and negative A. So any two numbers are additive inverses. Okay, what I'm going to do is I'm going to obviously stop here because it's time. Tomorrow I'll be going in and changing all the dates and fixing all that. My internet wasn't turned on at home, so I wasn't able to go do that before now. But so I'm going to go in and change all the dates. We will probably try to finish up chapter 2 on Wednesday because we're getting kind of far behind right now. So we may not be able to, but we'll that's the goal.
Yeah, well, at least attempt it.